Hello everyone, this side Dr. Nitin Sharma, Department of Information Technology, Ajay Kumar Engineering College. So today we are going to discuss about a normal form in theory of computation. So there are two type of normal form in theory for computation. First one is this one, Chomsky normal form, and second one is the Greibach normal form. Okay. So this is basically the outlines which we discuss in the next few minutes. So first of all, we discuss about the introduction, what is basically the context-free grammar, which we are going to convert into a normal form. Okay. Then we can understood what is Chomsky normal form, how we can convert a context-free grammar, convert into a Chomsky normal form. Then after that, we can go for the Greibach normal form. So step by step, we can just initially understood what is context-free grammar. So if we can see here, the context-free grammar is basically consists of a four tuple. First one is a V, T, T, S. So what is V? V is basically the collection of a variable, or we can say that the set of non-terminals. So set of non-terminal is called the V, and the set of terminal symbol, or we can say that the input symbols is called as a T, like AB. When we talk about a regular grammar or a finite automata, there are some elements which is under sigma. So these are the input symbols like AB, like 0, 1, like plus, minus. So these are the basically the input symbols. So here it is called as a terminal variable. S is the starting symbol. Basically we have some productions. P is basically the production which is given by the some non-terminal give a terminal and the non-terminal combination. So every production, if we can talk about so every production is in form of A tends to alpha form. So what is A? A is basically belong to V. So either any symbol from the set of non-terminal is taking as a right hand side A. And what is alpha? Alpha is basically the belonging of V union T star. So any combination of a terminal and non-terminal symbols together create a alpha. So alpha can be anything, like it can be a combination of small a, small b, and the combination of capital A, B, C. So this is the form you can create a productions. So these are the four tuple in the context-free grammar. So what we have to do basically, before understand the Chomsky normal form, you have to understand what is basically the grammar, how you can use it. So you can see there is a language L is equal to A to the power n, B to the power n, C to the power n, where the value of n is greater than equal to 1. Like number of A is followed by number of B is followed by number of C. So these are the productions which you can design any string which is generated by this language, you can also generate it by this grammar. For example, we can take a production S tends to, or yes, you can see this example. So initially you can see here, this is the production which we can use here, the first production. In the place of B, we are using here B, A. So changing the S values here, and we can putting the value, and at the end of that, we can generate a string. And you can see this string is basically generated by this language also. If we can take the value of n is equal to 2, so you can see A to the power 2, B to the power 2, C to the power 2. So this is basically the string you can generate it from this production. Okay. Now we talk about the Chomsky normal form. What Chomsky normal form basically do? So a context-free grammar is said to be a Chomsky normal form if all production are in the following production form. So what basically in this production form means, like A tends to small a, this one is basically a small a. Okay. So what is mean? A non-terminal give a single terminal value. Either production is in form of this one. Okay. So I have already written there, this A is in a terminal symbol. So a non-terminal give a terminal symbol, either production is this form, or either a single non-terminal give a combination of two non-terminal. So if all the production are in the form of these two production, either this form or either this form. So any production if is in the form of in these two productions, then this grammar is called a Chomsky normal form. So what we should do, whatever grammar given by the examiner or by any question. So like any grammar, suppose we are talking about S tends to A and S tends to AS. This is the grammar which is given by us. So what we have to do, we have to convert this grammar into a Chomsky normal form. So if you can see this is basically having a two production. One production is already in CNF, like S tends to A. It is already in CNF form because it is follow that one rule. Okay. But if we talk about S tends to AS, so we have to convert this production into a Chomsky normal form. How we can convert, we can discuss in few minutes. Let's fit. Okay. So before converting any context-free grammar into a Chomsky normal form, you have to follow the three simplification. So these are the three simplification you have to do initially. First is eliminate the useless symbol. Second is eliminate the null productions. Third one is eliminate the unit production. We can understand one by one with an example. So first of all, we discuss about the eliminate useless symbol. So what is the meaning of eliminate the useless symbol? That symbol or that production which is not generated any terminal values, or we can say that a non-generating symbols, we have to be removed from the grammar. Obviously, if any symbol are not able to generate any kind of output or any kind of a string, so what is the use of that particular symbol in our grammar? So what we have to do, we have to remove the ungenerated productions, then we have to remove the unreachable symbols. As you can see, I have already written there, X is a generating if X tends to W for some terminal string W, so you have to consider that production only. And if X is reachable, then you can only considerable. If any non-terminal symbol is unreachable, so you cannot include into that particular grammar. So first of all, we can take an example. Suppose this is the grammar. So this is basically the context-free grammar here. So S tends to AB / A, A tends to be B. What we have to do? First of all, we have to write the generated symbols. Okay. So like we have to write the only productions which is basically able to generate the string or generate the terminal symbols. So like we can understand here, S tends to A. S tends to A, basically it is generating a terminal symbol. Second is A tends to B. This is also generating a terminal symbol. These two production is directly generate the symbol, right? Or we can say that the generate a string. Okay. What we have to do with the next? Suppose if any production which can have this value S and A, then generate some string, then you can also include there. What we have to do? If we can put here S tends to, in the place of A, if we can put here B, then capital B. This is not generating any string. This is basically not generating any string. Why? Because this is a non-terminal. This is a non-terminal. This is a terminal value. What I need? We need symbols which is basically generate the string. That's why we have to consider only these S tends to A and A tends to B. What we done here, remove non-generating symbol. So this is basically the B is basically the non-generating symbol. So what we have to do, we have to remove these production from here. Okay. Once you identify any non-terminal is basically a non-generating symbol, you can remove all the productions which is having that particular symbol, that particular B. Next, now removing the non-reachable symbol. So before removing the non-generating symbol, we have this grammar, S tends to A and A tends to B. This is basically the identify reachable symbol. So you have to start with the starting symbol. You can start from the S. So if we go from S, you can just reach to the terminal symbol, that is A. That means A is basically the unreachable symbol. So you cannot reach A. How you can reach A? No, because there is no production between S2. There is no relation between S to A. So what you have to do, you have to remove this production because this is a non-reachable production. So you have to remove this. And finally, you have the answer only this one, that is S tends to A. So after removing the non-generating symbol and the non-reachable symbols, you can just get this one production only. Okay. So this is basically the step one. So this is the final answer. This is basically the given grammar, and this is basically the first step. Like this is grammar which we can get here after removing the unreachable non-generating symbol. Then what we have to do? We have to go for the unreachable symbol. So from this, you can just reach to S to A only. This is basically the final answer here. Okay, next is eliminate epsilon production. Epsilon production is what? Epsilon production, if any production is in form of this, A tends to be epsilon, means null production. So if you are solving any question and that question is having a epsilon production, so what you have to do, you have to be remove first. How? You can see this is a grammar, and if in this grammar you can see there is one null production. What is this? This is B tends to be epsilon. This is the null production. What you have to do? How you can remove this epsilon from this grammar? So first of all, what you have to do, you have to be write all the production other than the epsilon as it is. Okay. So in this you can see we can take this production S tends to ASA. Okay. So S tends to ASA. Now we have to put the epsilon value. So in the place of, if we can put a epsilon, so that B, if we can put here in the place of B epsilon, so we also get the A tends to epsilon. Also we can get the S tends to be epsilon. These two production are also generated when we put this epsilon into this productions, right? So we can put the value of epsilon here one by one. So what we have to do, first of all, we have to be put epsilon with this A, this one A. If we can put epsilon this A, we get AS, that has to be written here. Next, we have to be put epsilon for this A, right? So what we get SA, that we have to be written there, right? Next, what we have to be do, we have to be put epsilon for both A, we can put here S, right? So this is the way we can just put the values. Next, AB, if we can put the epsilon of this place B, so AB is here, then if we can put epsilon here, we can get here A production. These are the production we are getting here, right? This is the way you can just eliminate the production values. Next, eliminate unit production. What is unit production? Unit production is simply say that a single non-terminal is basically pointing out a single non-terminal. This kind of a production is called a unit production, right? Sometimes some students are going to be confused, like this is not a unit production, because a single non-terminal is pointing out a single terminal value. This is a terminal value. This is giving the output. But if I am talking about this one, a single non-terminal give a single terminal value, you can say this is a unit production. How you can remove? Remove is basically by using the transitive property. You can see here. You also we also discussed in the discrete mathematics. So this is basically the transitive property. If A tends to B and B tends to W, W is any kind of a string, then you can replace A tends to W. This is the way you can just eliminate the unit production, or you can say that the unit pair. Okay, let's see the example. So if we can see this example, this is a grammar and these are the pairs. Okay, I have written there, but you can see there are three unit production here. First one is this one, E tends to T. Second is T tends to F, and third is F tends to I. These are the unit production. So how you can remove them? So what you have to do, this is basically the cycle, right? So what we have to do, first of all, we have to be put, if you can see, F tends to I and I tends to this one. So what you have to do, you can write F tends to this one, right? So what is the final production for F? F tends to A slash B, IA, IB, I0, I1 slash E. So you can see, you can just simply replace the value of I in this cell. So F tends to I, the unit production has been removed and the updated production of F is this one. What next? Next you have to be replace this F value, this updated F value in this way. So this is also getting a without unit production. If you want to remove this unit production, then after that when you get that this T, you can put the value T here. So this is the way you can just remove the unit production from the grammar. Now we can go for the Chomsky normal form. Whenever you are going to solve any Chomsky normal form, whatever given, like context-free grammar, first you have to be pass the process for the simplification. Then you can convert into the Chomsky normal form. What this simplification, like we discussed earlier, elimination of the unit symbol, elimination of the null production, elimination of the useless symbol. Okay. Next, we have already read order of transformation. Add a new start variable, eliminate all the null production, eliminate all the unit rules, convert all these rules. Okay, so first of all, you have to be simplified, then you can convert it. Okay, now final steps. This is the grammar, Chomsky normal form. A Chomsky normal form is basically converted into this form, either this form, this form. We have already discussed about it. Now we have to be take an example. Okay, let's do this. This is basically a large example. I'll take an example for the small one. Like you can see, this is the steps. Arrange that all bodies of length 2 or more consisted only of variables. Breakdown of length 3 or more into a cascading of productions. Okay, how we can do? This is the example. You can just pause this video and understood it. I can explain with a small example. Suppose we are having this one. These are the two productions which I want to be converted into a Chomsky normal form. Okay, what you have to do? This production is already in CNF, right? So no need to be converted into a Chomsky normal form. What we have to do with this production? Sometime what basically student do? S tends to A, and S tends to A is already given. So what you have to do? You can just write here S tends to SS. So this is also converted into a Chomsky normal form, right? But this is a wrong way. Why? Why? Because if you are putting in the place of A S, because there is one more production, S tends to AS. So this S is having a two value. Either you can put a or either you can put a AS. So when you are putting a, this production we can receive. But if we can put here AS, so we can generate a new production, that is S tends to ASS, which is not given in this particular question. That means the machine is working wrong, right? So what you have to do? There is a golden rule. You have to be assume a non-generating symbol equivalent to a generating symbol, that is A only. This is the production which I am going to be assumed, right? So what update in this production? S tends to A1S. So you can see this production is converted into a Chomsky normal form, right? S tends to A1S. These two are the two non-terminals. This kind of production is in Chomsky normal form. What is A1? A1 tends to A. It is this new non-generating symbol, this non-terminal is also generate a terminal. So this is also a in a Chomsky normal form, and this production is already a Chomsky normal form. So this is basically the final answer. So this grammar, after converting into a Chomsky normal form, this is basically the new grammar which is in a Chomsky normal form. Okay, you can just pause and see this example. Okay, I'll take one more example here, then we can go for the Greibach. Suppose there is one more example. We can take AAAS and S tends to similar to the previous one, like this one. Okay, so what we have to do? We have to be assume A1 tends to A, right? So we can just do S tends to A1, 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 A1. I am solving the second one. Okay, so this is the basically the production update. Now what we have to do? We can just assume this one is A2. So now the updated is S tends to A2, A2, because this is also A2, this is also A2. So this production is in Chomsky normal form. What is A2? A2 is, this is also in Chomsky normal form. What is A1? This is also in a Chomsky normal form. So these three production, if you can see, all three production are in Chomsky normal form. Now we can convert into this one. If we can take here S tends to, we can just write here A2, A2S. Now you can assume this one is A3. So the updated is S is equal to A3S. And what is A3? A3 is A2, A2. So this. These are the productions which basically given context-free grammar converted into the Chomsky normal form. These are the production which is giving the output in a Chomsky normal form. Okay. So this is way just you can replace the one variable to the other variable. You can convert into a Chomsky normal form. It is so easy. Next is Greibach normal form. What is Garibach normal form? Garibach normal form is basically say that every production is in form of A tends to small a x. What is x basically? This is basically a alpha is a terminal symbol. Okay. What is x? X is basically a sequence of non-terminal symbol. It may be empty. What basically I can just, this is the mathematical representation. X is basically belonging to the V star. Star is basically say that it may be null, right? So it may be null. It may be null. So yani ki that means A tends to small a is in, it is also a Garibach normal form. Or what x is basically any combination of a non-terminal. So we can say write that A B C D. A tends to A B C. A tends to AA. These three all are in basically a Garibach normal form, right? Now, how we can solve this? So this is basically the example here given that. So what you have to do, eliminate the left recursion. So first of all, we have to be check. There is no useless symbol. There is no null production. There is no unit production. So how you can be solved? You can solve by the left recursion only. Okay. What is left recursion? Left recursion is like, just a minute. Okay. So what is left recursion? Okay. So you can see, I'm going to solve this production. A4 tends to this one. Okay. So what left recursion say that if A tends to A alpha 1, A alpha 2, then beta 1, then beta 2 and so on. If any production in the form of this, why it is called left recursion? Because it is a left recursion relationship. Okay. So if any production in this form, then the solution is A tends to alpha 1, alpha 2, beta 1 z and beta 1. Okay. Next, z tends to alpha 1 z and alpha 2 z, alpha 1 and then alpha 2. This is the way you can solve the using left recursion. What we can do, we can just explain with the next example, or you can see that this one example. If A4 tends to, this is the alpha 1, this is basically the A4, A4 is here. So this is an A alpha 2, this is beta 1, this is beta 2. So what they do, A tends to alpha 1 z, beta 1 z, and z tends to alpha 1 z. This is the way you can just solve them. Now, this is the question which you can solve by yourself by using the left recursion. Okay. How you can solve it? So, this is basically this one and this one. This is already in Garibach normal form. So, what you have to do? You have to make a left recursion setup. Okay. So, how you can do? You can write here S tends to XA slash. In the place of B, because we have to create a left recursion relationship. So what we have to do, we have to put this B value, the left B value. So then we can get the left recursion. So in the place of B, we can write B slash SB, then B. Okay. So S tends to XA slash B slash SBB. Now it is in left recursion form. If we can compare this, A tends to beta 1, beta 2, S alpha 1, or we can say that right, A alpha 1, right? So if we can compare A, so it is like in a left recursion form. So alpha 1 is double B, beta 1 is XA, and beta 2 tends to B. Now you can apply the left recursion. Then after that you can convert this S into the Garibach normal form. Similarly, you can apply into the B also. Okay. Because when you get the S in a left recursion form, or S is basically in a Garibach normal form, you can just put the value of S is here. So you can see B is also in a Garibach normal form. Okay. So every context-free grammar that does not generate basically the empty string can be simplified to the Chomsky normal form and the Garibach normal form. Derivation tree, you can just create a derivation tree. Whatever you are solving, you can just generate the tree for the particular string. In the Garibach normal form, a string of a length n has a derivation of exactly n steps. Grammar is normally formed for facility proof. Chomsky normal form is used as a starting point in the algorithm of CYK. So thank you so much. You can just do some practice. If you have any query, you can put on into the chat box. Thank you.